Hi, welcome to this video. In today's video, I'm going to look at a very interesting series. It's called Fourier series with complex numbers. Okay, let f of x be defined on an interval minus pi. Okay, we have Euler formula. We have e to the I phi equal to cosine phi plus I sine phi. Okay, this one is giving us, also we have e minus I phi equal to cosine phi minus I sine phi. Okay, I'm going to add the first equation. On second equation, I will have to the I phi plus e to the minus I phi over 2. Same thing with sine phi equal to, what I'm going to do now, in order to find cosine phi, just add in the first equation on the second equation is giving us this one. Okay, and for the sine phi, we're subtracting the second equation from the first equation and adding both sides, and you will end with this one. Okay, so this one implies cosine and phi equal to e to the I and phi plus e to the minus I and phi over 2. Okay, for the sine and phi equal to e to the I and phi minus 2 to the minus I and phi over 2i. Okay, what I'm going to do now, I'm going to make the combination between Euler formula and the Fourier series. Okay, so as you see here, as the Fourier series function f of x equal to e sub naught over 2 plus the sum of a sub n cosine n x plus b sub n is multiplied by sine n x. Okay, as n goes from 1 to plus infinity. Okay, what I'm going to do now, I'm going to plug cosine n x with Euler formulas. Okay, so I will have f of x equal to a naught over 2 plus the sum of a sub n, which is a sub n is multiplied by cosine n x with this one, cosine n x. So I will have cosine, which is a sub n, cosine I n x. I'm replacing phi with x. Okay, it will be the same thing. So e to the I n x plus e to the minus I n x over 2 plus b sub n is multiplied by sine n x, which is this one, which is e to the I n x minus e to the minus I n x over 2i. Okay, so now f of x equal, I'm going to put a to the I n x and a to the minus I n x as multipliers. Okay, so I will have a to the I n x over 2 is multiplied by a sub n plus b sub n. Okay, as n it goes from 1 to plus infinity, and plus a to the minus I n x over 2 is multiplied by a sub n. This one, b sub n, is divided by I. Okay, so this one is sub n minus bn minus b sub n over I. Okay, so what I'm going to do now, I'm going to simplify this one a little bit. Okay, so I will have f of x, the sum of e to the I n x over 2 as n goes from 1 to plus infinity a sub n. What I'm going to do now, I'm going to, if you take a look at b sub n over I, we have b n. I'm going to simplify this one, b sub n over I, by multiplying numerator and denominator by minus I. Okay, so we'll have minus I b sub n. I is multiplied by I is giving you minus 1. With this minus 1 it become 1. Okay, so I will have the same thing with the second term. So I will have e to the minus I n x, okay, over 2 is multiplied by a sub n. I'm going to multiply numerator and denominator by minus I as a complex number is giving me plus ibn, okay, over 1, because I is multiplied by I is giving me minus 1. With the minus 1 it is become 1. Okay, what I'm going to do now, I'm going to bring this one at the top and continue with our problem. The last expression that we have the f of x equal to a naught over 2 plus the sum of a sub n minus I is multiplied by b sub n over 2 is multiplied by e to the I n x plus a sub n plus I as a number complex is multiplied by b sub n over 2 is multiplied by e to the I to the e to the minus I n x. Okay, this is this one and this one are called the Fourier series coefficients. Okay, so set c naught equal to a naught over 2 and c sub n equal to b sub n over 2 and c minus n equal to a sub n plus I b sub n over 2. Okay, this one and this one and this one are called the Fourier series coefficients. Okay, so this one is expressed, this one is written on this form, f of x equal to, as n goes from 1 to plus infinity, okay, 1 over 2 pi as a periodic function, okay, from pi to pi. Okay, f of x is multiplied by e to the minus I n x dx. Okay, this is the Fourier series with complex numbers. Okay, if it is necessary, it's necessary to expand f of x of period 2L, okay, of period 2L, we have f of x equal to sum of c sub n, as n goes from minus infinity to plus infinity. Okay, cn is multiplied by I n pi x over L with cn equal to 1 over 2L integral of minus LL. Okay, f of x is multiplied by minus I and pi x over L dx. Okay, with n 0 minus or plus 1 minus or plus 2 and so on. Okay, this one it's often used in physics and other sciences. Okay, I will see more examples with details in next videos. Okay, Now I have done with this video. I will see you in next time. Thank you for watching. Bye.